Hi, perfect, excellent. So welcome to our live stream today. And you might have noticed we started a bit late. What would a live stream be without some tech glitches? So thank you for your patience. My name is Raya, and I am super excited to share with you some of the space that I'm in right now. So I'm up in Richmond Hill in the GTA at Lake St. George. Some of you might have been here in the past. And we are going to be talking about ecosystems. Now, before we get going, I just want to share a few things. So if you have any questions or comments, by all means, put them in the chat. You might have a worksheet. You can either do it now or after. If you don't, that's totally fine. So if you would like a worksheet to do afterwards with your students, then there is a link going up in the chat shortly where you can register for one or request one. And I just wanted to also mention that we'll be meeting Jasmine later during this session, and we have Will as well helping us out. So again, my name is Raya. Looking forward to our session today. Usually we come to schools and do programs under like a Watershed on Wheels kind of umbrella program where we do programs in the schoolyard all about the environment and about nature. And since we can't do that right now, we're reaching you virtually. So like I said, we are talking about ecosystems today. And ecosystems, they're kind of like habitats, except there's a lot more going on. So a habitat is kind of a place or an area that provides food, water, shelter, oxygen. An ecosystem, the word system is right in there. And so that means that there's interactions happening. So when you're looking at it, thinking about a system, you're thinking about things interacting with other things. We're going to do a bit of an exploration in this area behind me and have a look at some specific interactions that can happen in different natural spaces. So let's get started. I'm going to flip my screen around, and I have a bit of a question for you that you are welcome to answer in the chat. And my question to you is, looking at this, we've got a bit of a transition zone here. So we've got forest transitioning to a bit of an open space like a meadow. So looking out at the forest space, for instance, the trees, what do you notice is different right now versus, let's say, what you'd see in the summer? And I'm hoping that you're thinking, Raya, the trees don't have leaves on them, or at least some of them don't have leaves on them. And that's correct. So one of the interactions that happens, there is a helicopter flying overhead. I don't know if you can hear that or not. I'll let that pass by, just like in real life, letting it pass by when we're on field trips. So one of the interactions that happens, I'm going to take my mitten off so we can get things in focus more easily, is that as the days get shorter, we say, there's still 24 hours, but there's less sunlight every day in the fall, then trees start to think to themselves, well, we have all this chlorophyll in our leaves. It took a lot of energy to make that chlorophyll. Let's resorb, let's bring that chlorophyll back into the rest of the tree, because it's not going to do any use in the leaves without as much sun. And it actually breaks the chlorophyll down and saves the parts. So nitrogen especially is really hard for plants to, it takes a lot of energy to get nitrogen into them. And so they want to save that. And at that point then, the leaves aren't really that useful. So with the chlorophyll coming in, that's why they change color. The other pigments, oranges and reds, can show off. And the trees are also responding to the cold and realizing that, well, if there's water in the leaves, then when it gets really cold, that water is going to freeze. And what happens to water when it freezes? Well, it expands. You've seen that in ice cube trays. You fill an ice cube tray with water, and when it's turned into ice, then the ice is actually taking up more space than the water took up. So if leaves have water in them and that water expands when it freezes, that's just going to break the leaf anyway. So it just makes sense that the trees would drop the leaves. So in response to shorter days and in response to cold, deciduous trees drop their leaves. There's an interaction right there. If we come around here, we can see that some trees still have their leaves. So in this case, the leaves can also be called needles. We're looking at a spruce tree here. And they also respond to the cold. So if the water in these needles was to freeze, it would do the same thing. It would expand and break the leaves. But the leaves, or the needles, they actually also have something in that, mixed in with that water, that's kind of like an antifreeze. It causes the water to freeze at a lower temperature. And that means that if you had a regular amount of water, just water freezing and it expanded, in this case, it would have to go to a lower temperature to freeze, and that means that maybe we're not getting to those temperatures and it doesn't freeze. So they have a response by having something else in the needles that acts sort of like an antifreeze. So we've seen some interactions there. We've been talking about trees, but of course, other animals interact to these kinds of seasonal changes, like bats, they hibernate, raccoons, they'll go into a state of torpor. And we're going to now look at another animal-plant interaction in this case. So this one is milkweed. What am I looking for here? See if I can find it. This looks like it might be, maybe it's aster? Hard to tell in the winter sometimes, but I think that's what that one is. Oh, that looks like a really cool plant in this sort of meadow ecosystem that we're in, kind of a mini meadow. Ah, here's what I'm looking for. You might have seen this. This plant is called goldenrod, and the interaction that I'd like to share with you here is what happens between a particular organism called a goldenrod gallfly and the stem. So a gallfly will lay an egg on the stem, and when the egg hatches, out comes the larva. The larva burrows into the stem, and the stem, the goldenrod plant, responds by producing a kind of a swelling. It's called a gall. It's actually really, really tough. And, whoops, maybe you can put up the picture of what it looks like inside the gall. So the little tiny larva that comes out of the egg and is inside that gall, they spend the spring and summer eating the plant material, and in the winter, when it's really cold, they don't really do a lot of development. So they're in there the whole winter, and then when the temperature warms up again, out they come as an adult fly. They fly around for about 10 days or so. They don't even eat anything because they don't have mouth parts. And then they lay more eggs and then they die, basically. So most of their life is inside this gall. So the plant, it doesn't hurt the plant. The plant responds to the larva in there by producing this gall. So there's another interaction. Now there are lots and lots of other types of galls. There is a moth that actually also uses the goldenrod to produce a gall, and the gall is kind of a longer, elongated gall rather than a perfect circle. There is a midge that produces a bunched gall. So if the midge larva goes in, the plant responds by, it doesn't really grow any more stem, but it grows a whole bunch of little tiny leaves. So it looks like a whole bunch of leaves. So there are lots of relationships between insects and plants that happen. Now a couple of more, I'm just moving, sorry about that guys. I'm going to flip my screen around. I'm using a stabilizing device, and sometimes it gets a mind of its own and it's hard to keep track of where it's facing. So we've seen some interactions between our trees and the amount of sun and cold, and the insects and the gall. We talked about raccoons, and we mentioned bats a little bit. Birds also, if you think about birds who migrate, why do they migrate, right? What's that signal? Well, they will respond also to the amount of resources that are available. And a lot of birds who eat insects, well, if we're not seeing so many insects this time of year, then the birds are going to decrease. And what do insects respond to? Well, we just saw. If they are hiding out in galls, or maybe they're in the leaf layer, they're not flying around, they're not so easy for the birds to come across, then without so many insects, the birds decrease. And what we're seeing is a chain reaction. So insects responding to temperature changes can cause the birds to respond by migrating away because they don't have resources. And so there's a chain reaction from one element in an ecosystem impacting another, impacting another. Everything is connected, right? Monarch butterflies, when they fly south, they're responding to changes in the amount of sun, the temperature, and even the quality of the milkweed plants that we have here. There is their decision to fly south. So we've been talking about these different parts of an ecosystem and how they interact. And there are words for this. We've been talking about some living things: butterflies, birds, insects, plants. These are the biotic parts of an ecosystem. all these living things. Bio means life, right? And we've mentioned some abiotic elements of an ecosystem. So temperature, amount of sun, precipitation's another one. These are non-living components of an ecosystem that do have an impact on the rest of the ecosystem. So when we're thinking about, again, the idea of ecosystems, it's a system of elements that interact together. Whether they're living or not, they have an impact. Now I'm going to show you one more kind of ecosystem. We're just going to head inside in a moment. I have it set up in there. But just before we do that, I'd like to find out who's here today. So we're going to put up a straw poll. Basically, it's a link. There's one question. And we'd love for you to check on if you're watching with a class of students, or if maybe you're homeschooling, watching with children in your care, or maybe you're an individual who just wants to learn more about ecosystems. And so you are tuning into our session today. And you're hearing the door. One moment. There we go, heading inside. Thank you for completing the straw poll. Now, if there have been a couple of questions that have come up in the chat, I can take them at this point. And has anything come up? I'm going to put my mask on. Nothing yet? Okay. So, the other ecosystem I wanted to share with you was a soil ecosystem. I actually brought my own personal vermicomposter bin. Vermi means worms, and it's a very small bin relative to other people's vermicomposter bins, so you can kind of see. They love apples and bananas. You can see a little apple, oops, where is it? You can see an apple sprout coming up there. There we go. From the seed, which isn't the goal of the composter, but it happens. I put a carrot top in here. They don't love starchy things, but there's some carrots sprouting, which is kind of cool. And what I'm going to show you is actually, under our microscope, maybe we'll see some of these organisms living in this system. So let's get this focused on our soil. All right, what we're seeing here is an apple I ate the other day, and I put it into the bin. And if I move this around, it'll be out of focus for a moment, and then I'll focus it up again. Let's see who's under the apple in this soil. So this isn't strictly speaking an ecosystem, because it is something that I'm contributing to with putting food in here. But soil, we often think of as not really being that active, especially in winter. And it's very, very active. Where'd you go, little buddy? See if we can find them again. I don't want to disturb them too much, but I do want to show you, really bring this idea to the forefront. There we go. That there's a lot going on in soil. Oh, so here we have some springtails, some little decomposers that are wondering why they've been disturbed. So these are actually, I believe they're related to, if you've seen like snow fleas, the dark insects on snow. It doesn't have to be that warm for them to come out. They're also a type of springtail. Strictly speaking, they're not an insect because they don't fly exactly. All right. And here we go. Springtail and a red wiggler. So a red wiggler is a species of worm that is actually native to Canada. So the night crawlers we usually see, they're not even really native to this area. These guys are, I'll stop moving my piece around there, let the worm do his thing. So these guys are thinner, they wiggle, they're redder. That's how we can kind of tell the difference. And this is what people usually have in their home composters. Now the point of this is to kind of demonstrate to you that soil, the soil ecosystem, needs to have these decomposing components to be healthy. And soil health, of course, impacts plant health. So having a healthy soil ecosystem can help you have a healthy meadow ecosystem and forest ecosystem, and it's all tied together. Now, something that can impact our soil ecosystem, see if I can get one more little shift here to see if there's one more spot. Maybe there's another organism we can go before I switch topics. Oh, they're just so cool looking. Oh, there's a little brown guy in there too. Excellent. On the side of the worm. I'm not sure if you can spot him. All right, so the soil ecosystem can actually be damaged by some things that humans do. We haven't really talked so much about human impact on these different spaces and these different elements of ecosystems. One of them I'd like to share with you is the idea of something we do in the winter, which is salting the sidewalks, right? Or the roads. Human safety is important, of course, but I'm going to show you a picture. And in this picture, you can see that one little grain of salt, or one kernel of salt, one particle there, can actually help to melt a fairly large amount of snow. Now, usually, people put a lot more than this amount of salt down, but this is all that's needed. The more salt we put, then that means there's more salt going into soil ecosystems, which means that the salt is hanging onto the water, and it's actually potentially drying out the roots of plants, so it's damaging our meadow and forest ecosystems. Salt can also end up going into our storm drains, which means that it ends up in Lake Ontario. And if it's in Lake Ontario, then it's impacting an even broader ecosystem. And there are so many different kind of micro-ecosystems on the edge of the lake, right? Wetlands and shorelines and things like that. So salt can have a huge impact on really sensitive species in these spaces. Now, there's another impact. There are lots of impacts we can have. There's another one that we're going to share with you today that can affect Lake Ontario as well. And Jasmine is here to share with us this other aspect of human impact on our lake ecosystems in Ontario.
Great, thank you so much, Raya. So what I am going to be talking, and hello everybody, my name is Jasmine, nice to meet you. What I'm going to be talking about today is Asian carps. So Asian carps are a group of fish species, and they're a really great example of how humans can negatively impact our environments and our ecosystems, and why it's so important that we're aware of our impacts. We're trying to kind of prevent the damage that those impacts can cause. So Asian carps are a group of fish that were introduced, they were brought over by humans to the southern United States in the 1970s. And over the past, 50, 60 years, these fish have been moving throughout the United States, and they've been moving north. So they've been swimming up rivers like the Mississippi River, and they've been coming further and further north. And now we're concerned here in Canada about them becoming established in our Canadian waters, like our local rivers, streams, and Lake Ontario. So why are we worried about Asian carps becoming established here in Canada? Well, the reason is because they are an invasive species. So we know what invasive species are. We know that they're not good for our environment. The reason why some Asian carps are invasive is because of their behaviors. So one thing that Asian carps are great at is eating. They can eat and eat and eat. They can eat up to 40% of their body weight in one day. So for someone like me, that would be like if I ate 60 pounds of food every single day. That's hundreds and hundreds of bowls of spaghetti. That's so much food. And if we're thinking about that, then we can imagine how much these Asian carps are taking away food from other native species. So I'm going to pull up a picture now. And this picture is going to show what a healthy ecosystem looks like. So we can see a healthy ecosystem here. We have amazing fish biodiversity. We have amazing biodiversity of our birds as well. We can see our water is very clear. We have a lot of aquatic plants growing. We have a lot of above ground plants growing as well. All in all, this is a healthy, balanced ecosystem. But now I'm going to show you a photo of what happens when Asian carps become established in an environment. So here we can see that we have, instead of our amazing biodiversity of different fish species, we really only have one group of fish, and that is our Asian carps. And they are taking over As they're eating and eating, obviously we can see that they have taken away all of these plant species. And we know that ecosystems have a limit on how many living things they can support, right? There is a balance there, and this is an example of how humans have impacted and disrupted the balance in this ecosystem. So there's not enough plants to support different fish species anymore. There's not even enough plants above ground to support different bird species either. So this is no longer a healthy ecosystem, and this is no longer a balanced ecosystem. Okay, so now we know a little bit about the history of Asian carps. We know kind of the threat of them and the damage that they could cause. We're going to learn more about kind of what they look like, and we're going to get into some fish ID. So I mentioned that there are 4 Asian carp species. We are going to start off by talking about 3 of them. And these are the black carp, bighead carp, and silver carp. So I'm going to show you our first fish here. And what's fun about these is you can kind of tell what they're called just by looking at them. So I'm going to hold up this fish. And these are really fun. They kind of move just like a fish. And I want you to tell me whether you think this is silver carp, black carp, or bighead carp. So let's see. I'll hold it close to the camera. What do we think? Okay, if you said black carp, you are right. This is our black carp. Amazing. I am going to hold up our other 2 Asian carps that we're going to be talking about. And let me just get a hold on them here. They're kind of heavy. Here is one of them. So we'll call this fish A, and we'll call this one fish B. Now I want you to think. So one of these is called a silver carp. One of these is called a bighead carp. So let's think about the names and try to guess. Do we think fish A is silver or bighead? What about fish B? Is fish B a silver carp or a bighead carp? What do we think? Okay, so fish A is actually a silver carp, and fish B is our bighead carp. We can see that it's kind of named after this huge head right there. Okay, so the reasons I talked about these 3 Asian carps first is because they're not so much of a threat to Canada. We've only found the bighead carp in Lake Erie a few times, but we haven't really found them coming up that far north. The biggest threat to Canada and Canadian waters is our grass carp. I'm going to hold up our grass carp here. So this is a big model. This is life size. So grass carp can get this big. And I want to kind of talk about a few identifying features of this carp. So there's a few ways that we can identify it if we see it. And identification is so important because if we did see it in Canadian waters, then we would want to report it. And we'll put a link in the chat of where you would go to report an Asian carp like our grass carp here if you saw it. So when we're thinking about identifying our grass carp, the easiest way is to compare it to another another fish species that you might see in Canada. And that is our common carp. So I'm going to hold up our common carp here. And this is actually also an invasive species. But the difference is that common carp is established in Canada. So it's almost like a warning story. We know it's here, and we really can't stop it from being here. It is established. But what we're working on now is just trying to control it. So if we see common carp, we don't need to report them. If we see grass carp, we do need to report them. And there are 3 main differences between these fish. So with common carp, you can see that they have a long dorsal fin on their back. So dorsal just means upper side or back. They have a long back fin here. And then our grass carp, does it have a long dorsal fin or a short dorsal fin? It is a short dorsal fin. That's right. Okay. So that's one of the biggest differences and how we can tell them apart. The second one, and this one might be a little harder to see, is something called barbels. So I'm going to hold this up here. You might be able to see it. Our common carp have barbels that stretch down out of the mouth. And this is what helps them detect food and kind of see in really cloudy, murky water. Our common carp does not have any barbels. It is barbelless. So that is a really great difference between these two fish. The last one is a little trickier, but we can see with our common carp, they have their eyes more at the top of their head. And with our grass carp, the eye is right in the middle of the head. It's kind of parallel with the mouth. So those are the three main differences between these fish. I'm going to put this guy down, this big guy. And the last thing that I want to show you all about Asian carp is...
Oh, there was a question actually, just
amazing.
before we switch to the next piece. Kalimba was wondering, can we eat these fish?
Oh my gosh, that is a great question. And you know what? I'll be honest, I have never tried to eat these fish before. What I do know is that common carp is a really popular fish here in Ontario. A lot of people like to fish for it. A lot of people like to eat it. Apparently, one of the things that they're doing in the southern US to control our Asian carps from kind of spreading is encouraging people to go out and fish them and eat them. So apparently they taste pretty good, but I'm not speaking from experience. Great question, thank you.
We've just had an answer come in that Asian carp of all types have white, firm, mild flesh, which is excellent table fare, but all Asian carp also have intramuscular bones in the fillets that many people find undesirable. So
Yes.
if you're looking for more detail there.
Interesting, okay. So let's recap what we've learned so far. So we've learned about the history of Asian carps. We've learned about kind of the threat and the damage they can cause to our ecosystems. And we've learned how to identify them. So we've learned about all the different types of Asian carp. And now what I want to talk about is prevention. So I want to talk about what we can actually do to prevent them from coming here and becoming established in Canada. So we are going to go over here. And I have this amazing board here, and it is painted as a river. So we have a river that's flowing down, down, down into Lake Ontario, right at the bottom here. So we can imagine if this is the United States up here, this might be an area where we have Asian carps living. And if they are able to get through this river successfully, then they will be able to establish in Lake Ontario and then become established across our Great Lakes. So let's try this out. We are going to be using these little guys, and these will be our grass carp, okay? And let's see if they can make it to Lake Ontario. Ooh, yes, it made it, okay. Now let's think, what kind of preventative measures can we make to stop grass carp from getting all the way to Lake Ontario? Well, one of the things that people are doing is they're setting up electric barriers. And these electric barriers send electric currents, and they kind of prevent fish from going past them. So we're going to use one of our barriers, and I'm going to put it right in the middle here, okay? Now let's see if that can stop grass carp from getting to Lake Ontario. 3, 2, 1. There we go. Okay, so just one electric barrier did not do the trick. Let's think of some other prevention measures that we could try. What if we tried to do some monitoring? So one thing that we are doing here at TRCA is we're monitoring for Asian carp. We're going out all the time to monitor. So let's say we set up some monitoring right here. And we're going out. If we see any fish, we're removing them. That could be one way of preventing them from being established. Let's see if our grass carp makes it through now. Oh my gosh, it's still making it through. Okay.
It was slowed down though.
It was slowed down a little bit, that's right. So our last kind of prevention measure that we can think of would be maybe one of you is going out and you're going fishing. And you've remembered your ID skills and you see one of these grass carp, you identify it and you report it. Well, that could be a really effective way to stop grass carp from making it to Lake Ontario. So let's try, we'll put one more barrier, we'll put it right here, and let's try again. Okay, and we stopped our grass carp. Yes. So we can see that by working together, by using electric barriers, by doing monitoring, and by sharing the Asian carp story with your friends and families, sharing your identification skills, these are all some really great ways. By working together, we can prevent Asian carp like the grass carp from becoming established here in Lake Ontario. And if you want, you can check out, we'll put a link in the chat to our fact sheet, and that has a lot more information for you to learn.
Excellent. Thank you, Jasmine. I'm just switching my screen here. Little backlit. All right. So we have learned about ecosystems in general. We've learned about abiotic, biotic factors in ecosystems, how these different elements interact with each other. And we discovered some human impact. So using a lot of salt, for instance, more than we need, can cause a negative impact on Lake Ontario and on the other ecosystems, soil and then meadows and so forth. And also, we learned about what we can do to prevent the Asian carp from making their way into Lake Ontario, and some things that are currently being done as well. At this point, if you need to be off, because I think it's been about half an hour since we started, you're welcome to, but we do have time for some questions, and we'd love to hear from you if you have any questions that you would like to ask. I'm seeing Will nodding. All right, Will.
If you put a barrier, then won't other fish not be able to come to Lake Ontario?
If we put a barrier, then won't other fish not be able to come to Lake Ontario? Jasmine, our carp expert, do you have thoughts on that?
I do, yeah. Thanks so much, Raya. So that's a really great question. That's something we definitely need to consider. With these electric barriers, we can use different types of power sources. We can kind of send different charges to deter different types of fish. So that's one way we can kind of target different types of fish. Another way is by using some mechanical barriers. So we have these actually in Toronto, down at Tommy Thompson Park, and what they look like is basically a fence. And they're a fence, but they're underwater. So they're these set of metal bars. And these bars are big enough to let smaller fish pass through, but they're small enough so that our big carp, like our grass carp here, cannot get through. So that's another method of allowing some fish to pass through, but preventing our invasive fish. Great question. Thank you.
Thanks, Jasmine. Will, were there any other questions that turned up in the chat at this point? Not right now? Okay, excellent. So we'd like to thank everybody for joining in. If you do have other questions, you can put them in the comments once the video has loaded onto YouTube, which should be shortly after the session wraps up. And we can check back and address the questions then. I would also like to mention that our next YouTube live stream, Nature in Your Classroom live stream, is taking place on February 24th. And that one is directed for grades 4 students. We're talking about habitat. So kind of connected to some of the things we've talked about today as well. But you can tell your friends. We encourage you to continue getting outside, continue exploring as long as it's safe to do so. And even when you're outside walking in your urban areas, like in your city streets, depending where you live, then, or your suburban areas, see what you notice as far as interactions are concerned. There are a lot of interactions that take place between animals and other wildlife that are in our urban spaces. So thank you very much for joining, everybody. We're going to sign off now and see some of you maybe in a couple of weeks.